Imagine you are organizing a big family reunion and you have got two lists. One from your mom's side of the family and one from your dad's. You want to identify family members who are common to both lists, because these are the relatives related to both your mom and dad. This task is quite similar to finding the intersection in mathematics, where you seek out common elements between two sets. For example, the common elements between these two sets are the following numbers. In the world of programming, especially when dealing with collections like arrays or lists, we often face similar challenges. How to find common items between collections. This is precisely where LINQ methods like intersect and IntersectBy come into play. So, what do these methods do, and when and how should we use them? In this video, we are going to delve into both methods. Starting with intersect, this method allows you to find the set intersection, which simply means it gives us the common elements between two collections. IntersectBy, on the other hand, is a bit more specialized. It allows you to define a key for comparison, which is incredibly handy when working with complex data types, or when you want to compare elements based on a specific property. Let's begin with intersect. This method offers two overloads. The first overload is straightforward. It works with both sequences directly, without any need for expressions or a comparer. Let's see this in action with an example. We have the following two integer arrays. To find the common elements between these arrays, we use this query. The result is a collection, more precisely, an IEnumerable of integer, which we can convert to an array using the toArray method. This gives us the numbers present in both arrays. Let's take another example about data tables. Suppose we have these two tables, which contain different columns and rows. Our goal is to get the common columns between both tables. The result should be an array of string, that contains the column names, which are available in both tables. Here's the query to do that. The first sequence is the column names of the first table. Here we first retrieve the columns, cast them to data column type, then we read the column name, which is a property of data column type. This sequence will be the following collection, which contains the column names of the first table. It's an IEnumerable of string. The second sequence works exact the same like the first one, but here we get the column names of the second table. It's also an IEnumerable of string. This means, these collections are now the sequences we want to query. Using intersect method we get the following collection, which contains only the common column names in both tables. This will be also an IEnumerable of string. By using toArray method we convert this IEnumerable to array of string. This is how to use the first overload of intersect method. Moving on to the second overload of intersect, it's quite similar to the first but includes a comparer. There are situations where we need to be more discerning in how we compare elements, particularly with complex types. Let's consider data tables as an example. If we have two tables with identical structures and we want to find the exact same rows, we can't directly compare the rows without a specific comparer. That's when we utilize the second overload of the intersect method. Here, as enumerable is used to treat the rows of the data table as a sequence. So, we get an enumerable row collection of data row. And here is our comparer, which tells intersect how to find identical rows. The result of this query is a data table containing the following rows, that are identical in both tables. This is also how to use the second overload of intersect method in general. After exploring the intersect method with its two overloads, let's turn our attention to IntersectBy. This newer addition to the LINQ arsenal offers a powerful twist on the basic intersection concept, by allowing us to specify exactly what we mean by common elements. Imagine going back to our big family reunion scenario. This time, instead of just identifying family members, who are on both your mom's and dad's sides, you want to focus on something specific, like those who share the same last name or birth month. This specificity is exactly what IntersectBy allows us to achieve in the programming world. It allows us to define a key selector function, which extracts the value we wish to compare. IntersectBy also offers two overloads, much like intersect. These overloads provide flexibility in how we determine the common elements between two sequences, especially when dealing with complex data structures such as data tables, XML, or JSON. Let's explore each overload with examples tailored to these formats. The first overload of IntersectBy is particularly useful when you need to compare elements based on a single key extracted from each element. It has the following structure, where we have both sequences we want to compare, and a lambda expression to define the property. This comes in handy with structured data, where comparisons are often based on specific fields or properties. Let's consider data tables as our first example. Suppose you have two data tables representing guest lists from two events, and you want to find out which guests attended both events based on their email addresses. The IntersectBy method allows us to easily identify these common guests. Here's how you could write the query. The first sequence is the rows of the first table. The second sequence is the content of the column email from the second table. So, we have a collection of data rows and a collection of strings. Then we have the lambda expression, where we define the property we want to use. In this example, it's the email column. So, this expression refers to the first table. Its return type is of type string, which is the same type like the second sequence. This expression is exact the same like the expression of the except_by method, what we learned in the previous video. The result of this query will be the following table, which contains only these two rows, because the emails are available in both tables. So, Alice Johnson and Bob Smith attended both event A and event B, making them the common guests between the two events based on their email addresses. This is how does the first overload of IntersectBy method work. Now, let's advance our discussion by focusing on the IntersectBy method's second overload, which introduces a vital aspect to our data intersection tasks, the ability to use an inequality comparer. This becomes particularly valuable when we deal with case sensitivity issues, or when our data structures are non-uniform, such as varying XML and JSON formats. For our XML example, imagine you have two different XML documents, each representing a collection of books. In these collections, each book is identified not just by its title, but also by its publisher. However, publishers' names might be formatted differently across the documents, some in uppercase, some in lowercase. To find the common books by publisher name regardless of these inconsistencies, we would use IntersectBy along with a custom string comparer that ignores case. Here's how you would approach the task. Before the query, we have to parse the XML documents. We start with the descendants of the first XML document, selecting all the book elements. So, here we have an IEnumerable of X element. For the second sequence, we project just the publisher names of the second XML document into a sequence. Here we have an IEnumerable of string, where each string represents the publisher name of the book elements from the second XML document. Now, to intersect these sequences while ignoring case sensitivity, we use the IntersectBy method with string comparer.ordinal_ignore case as the comparer. This query returns an IEnumerable of X element, which we can convert to list using toList method. So, the query returns a list of X element, where the elements are present in both XML documents based on the publisher name. Let's take another example about JSON. Suppose we have the following two arrays of objects, where each object represents a guest with various properties, name and email. Each JSON array represents a list of guests, who attended one event. If we are trying to identify guests, who attended both of two events, we could again benefit from the IntersectBy method. We want to intersect by the email property. Let's implement this use case in UiPath. At the beginning we have both JSON strings. First we have to parse the JSON arrays as following. So, we parse the JSON string into JArray. The result of parsing will be stored in two variables of type JArray. Now the LINQ query using IntersectBy method. The first sequence is the first JSON array. So, here we take the whole array and it's of type JArray. The second sequence will be the property email from the second JSON array. This sequence is of type IEnumerable of string. Then we have the lambda expression, where we define the property we need from the first JSON array. This will be the email property. The last part is the comparer to ignore case. This query returns a collection of type IEnumerable of JToken, which we can convert to list of JToken using the toList method. So, the structure of this query is like the structure of the query for the XML files. After the query we have the following loop to print out the items from the result list. Here we are printing out the properties, name and email. Let's run the code to check the result. As you can see, we got these two objects, which are present in both of JSON arrays. So, these two guests attended both of the events. This is how to use the second overload of IntersectBy method. As we conclude our exploration of LINQ's intersect and intersect-by methods, let's recap their unique features and how they can be applied to different data structures in programming. The intersect method is straightforward, providing a way to identify the common elements between two sequences. It comes with two overloads. One that works directly with the sequences, and another that allows for a custom comparer, enabling more nuanced comparisons such as case-insensitive matching. On the other hand, IntersectBy extends this functionality, allowing us to define a key for comparison. This key is a specific property of the elements we are examining, making IntersectBy particularly useful with complex data types. Like intersect, it also comes with two overloads. The first overload compares based on a single key from each element, while the second provides the additional capability of using an 𝗖𝗵𝗽𝗀 comparer to refine how we determine commonality. It's crucial to note that with intersect, both sequences must contain elements of the same data type for the method to work. Meanwhile, IntersectBy is more flexible because the types of the two sequences can differ, as long as the key selected for comparison is of the same type. In practice, these methods offer powerful ways to find intersections in collections, whether we are dealing with simple data types, structured data like data tables, or even more complex structures such as XML or JSON. Through the examples we have walked through, from guest lists to book catalogs, we have seen how these LINQ methods streamline the process of finding common elements, providing clarity and efficiency to our code. Remember, intersect is your go-to for a direct intersection of elements, while intersectBy is your choice when specific properties or complex comparison logic come into play. By understanding and utilizing these methods, we can handle a variety of intersection tasks more elegantly, making our code not just more readable but also more robust.